Okay, example 6. The region bounded by the curve y equals to square root x. Let's suppose we have now the sketch y equals square root x. The line x equals to 1. Use a different color. X equals to 1 is this. And the line x equals to 4. And finally the x-axis. So it's quite clear that you want this volume. Now it's not rotated by x-axis, this time it's about the y-axis. So now you are talking about this volume. Now, leaving your answer in terms of pi. Now let's look at the diagram here. We are actually looking at, again, a hollow figure. Be very clear, we are actually looking at a hollow figure. Now, a hollow figure that is made up of two parts. If you look at region A, it is this hollow cylinder over here. Region B, it is a hollow figure, but it is this actually this part with a hollow inside. So we divide it into two. Why do we need to divide into two? Because if you look carefully at this curve here, okay, if you look carefully at this curve here, because you are actually trying to rotate about the y-axis, if you integrate 1 to 2 pi x squared dy here for this curve, you are indeed just going to get this part. But we don't want this part. We want B that is rotated. I don't want C that is rotated. If you use this formula, we're going to get C. So we must do some subtraction, yes, but let's identify the area first. Actually, volume first. VB is this. So we split it up like that. It's a lot easier. So how to find VA? VA is easy because it is a hollow cylinder. So I'm not going to use integration. I'm just going to say that this is, let's identify, this is the, let's look at A. The bigger radius is 4, the inner radius is 1. Correct? So quite easy. I'm going to say pi 4 square times 1 minus pi 1 square times 1. Correct? Because the height here, look here, is 1. Easy. VA is quite easy. Alright, and you get 15 pi. Now, what about VB? VB is tricky. Remember what I said just now, if we were to integrate this part here, rotate about y, if you use the formula, you are actually going to get this volume. Because it's bounded by the curve and the y-axis. So, in order to get volume VB, we've got to use cylinder minus this volume. Volume minus volume. Big volume minus small volume. So big volume is not difficult because, again, we can know the height, we know the radius, because big volume has radius 4. So we're going to use this. Pi 4 square times 1. Minus away the volume generated by the curve. It is integrate from 1 to 2 We call out this one is integrate pi x squared dy. Yeah. So what is x squared? Here. Pi x squared dy. So from here, x squared is actually y4. Correct? So before we write that, we write x squared first. Okay? Correct? Pi x squared is 1 to 2. Alright? So this is 16 pi minus, we factorize the pi out, 1, 2, x squared is y4. And this is 16 pi minus pi y5 or 5 from 1 to 2. And arithmetic will tell this is 49 pi or 5. So now we found VB. Remember, the entire volume is made up of VA plus VB. Yep. So just add the two and we get the answer. Alright, that's example 6.